In this video, I'd like to talk about pump parallel operation and especially highlight the following questions. When the pump parallel operation is effective and when it's not effective? What are common misunderstandings between pump users regarding pump parallel operation? What pumps have to be selected for parallel operation? How to define the pump operating points of pumps when they operate in parallel? What problems do pump users can meet at pump parallel operation? Pump parallel operation is when several pumps have a common discharge pipeline and every pump delivers liquid to the common discharge collector. Very often pumps have a common suction pipe, but not always. The total pump flow is regulated by the number of running pumps. The total QH curve of pumps operating in parallel can be built by adding flow of every pump at the constant head. On the slide, the total curve of 2 and 3 pumps are shown. I'd like to remind you once again that the efficiency of every control method of pumps strictly depends on the system curve. Let's consider how the efficiency of the pump system depends on the system curve at parallel pump operation. Let's consider how 3 parallel pumps will operate in a system with a high static head. In this case, the operating point will be at the intersection of the system curve and the total QH curve of 3 pumps. The total flow will be Q3. It's very important to define the operating point of every pump and its position on the QH curve. It can be done by projecting the horizontal line to the vertical axis. And at the intersection of this line with the single pump curve will be the operating point of single pump. In case of 3 pumps, it will be point 3. In case of 2 pumps, it will be point 2. And in case of 1 pump, it will be point 1. As you can see in the system with the high static head, the operating point moves slightly along pump curve and stay within the operating range when different number of pumps operate. Now let's consider how parallel pumps operate in the system with high friction head. We see the opposite picture. Turning on the next pump increases the overall flow less and less. Turning on the third pump increases the total flow by a very small flow. Also, we see that the operating point of the pump shifts toward less flows and less efficiencies, point 1, 2, 3. If we add fourth pump, the total flow will not be increased. This slide shows an example of the most common misconception among pump users. Very often pump users think, I have a pump with the flow 100 cubic meters per hour. If I need the flow 200 cubic meters per hour, I will add the same pump in parallel. If I need 300 cubic meters per hour, I will add the third pump and will have 300 cubic meters per hour. Let's look at the graph, and we see that in the system with high friction losses, this idea doesn't work. This graph clearly demonstrates that this is the false understanding. When we turn on the second pump, the total flow doesn't double. When we turn on the third pump, then the total flow increases by an even smaller value. The requirements for pumps curves. Wide application of pump control methods, especially variable speed pumping and parallel operation, dictates requirements to pump characteristics. Pumps with unstable QH curve are not recommended for application with variable frequency drive and parallel operation. Pumps with flat QH curves also are not applicable for the parallel pump operation. Why? Let's look at the two curves and their behavior when the system curve changes. The slight change of the system curve causes the large change of the pump flow with a flat QH curve. The use of pumps with an unstable characteristic can lead to the fact that one pump will operate at low flow outside the operating range. How do pumps of different sizes, heads, operate in parallel? If pumps have different heads, it is necessary to control the position of the operating point. We have two pumps with different QH curves. How they will operate in parallel? Let's build a combined pump curve. It will be pump 1 plus pump 2 curve. The pumping system has characteristic system curve. The operating point will be 1. Pump 1 will operate at operating point 1, 1. The pump 2 will operate at operating point 2, 2, which is very close to the shut off head, where pump operation is not acceptable. But sometimes users cannot notice it, and pump can operate in this mode for a long time, which causes mechanical problems. Possible problems with pump parallel operation. When pumps of different sizes are used in parallel, take care that pump with less head is not shut off by the pump with a bigger head. Identical pumps can have different QH curve due to tolerances, deviations, and degradations. This can cause pump operation far from the best efficiency point. There are not two identical pumps. Every pump is manufactured with some tolerances. It means one pump will generate more head than another. Pump degradation changes pump characteristic, and the pump will have lower head than other installed in parallel. Conclusions. Parallel pump operation is recommended for application in systems with high static head. Parallel pump operation is not recommended for application in systems with mainly friction losses. Connection of the next pumps does not increase the overall flow proportionally. Pumps of the same size is recommended for parallel application. Application of pump with different heads needs careful analysis because there is a risk of pump operation beyond the allowable operation range. Make your pumping system efficient. If you need more information, please visit our website pumpsaudit.com.